Okay, here are your empirical formula notes. You're going to want to write these 4 steps down in your notes. So you'll need to pause right here and make sure you have these steps written down to remind yourself what order to do everything in. Okay. All right, so this is the first example problem. What we're going to do is here are our 2 elements. We've got nitrogen and oxygen. These percents are going to be the mass that we start with. So for instance, they're going to work nitrogen in this first box. 25.9% is the mass, so I change it to G, grams, that we start with. Okay. Now, what we need to do is convert the mass to moles. Okay. And if you remember, our molar mass on our periodic table tells us how many grams are in 1 mole of each element. So look, grams mark out, and that's going to get us into moles. All right. So I converted nitrogen to moles, and it's 1.85. All right, the next step is to take our oxygen, and remember our percent just turns right into a mass, grams. I'm going to take oxygen's molar mass, which they just rounded to 16, that's fine, and cross out the G's to get it into moles. Remember, to get this number, they're just dividing this by this by this to get this number here. All right. Once you convert to moles, the next step is to divide by the smallest one. So between 1.85 and 4.63, 1.85 is the smallest number. So you divide all of your numbers by the smallest number. So you have to convert each element to moles before you do this next step, because you have to know what the smallest number is. In this example, there's only 2. So we converted them both to moles and then divided by the smallest. So one of them will always be 1, because the smallest number divided by itself is going to be 1 every time. Now this number, when you divide it, is 2.5. Now here's the tricky part about empirical formulas. They have to equal whole numbers. Our 1 is already whole, but 2.5 is not. So the very last rule that you wrote down said that you have to multiply by 2, 3, or 4 to get whole numbers. Well, if you're dealing with 0.5, like this one, then multiplying by 2 will make it a whole number, okay? So what we're going to do is, if currently these are the numbers that we have, if you multiply one of them by 2, though, you have to multiply them both by 2. So we'll multiply the 2.5 by 2, and it becomes 5. But we also need to multiply the 1 by 2 as well. So if you have to multiply to fix these decimals, multiply all of them. And those numbers that you're finding, those whole numbers, are the subscripts in the formula. So that's why you would have N2O5. All right. I'm going to show you another example that's completely worked out from the beginning to hopefully make it clear. And I've already got it a little set up, but I know that this is tiny and hard to see, but this is what it says. Determine the empirical formula of a compound containing 3.6 grams of carbon, 0.90 grams of hydrogen, and 2.4 grams of oxygen. So that's the problem. So I went ahead and set it up. I've got carbon, hydrogen, oxygen here, and I've got the numbers that it gave me in the problem put in my first box, in my dimensional analysis conversion box. Okay, so that's step 1. Step 2 is to convert them all to moles. Okay, so carbon's molar mass is 12.01 grams. Grams mark out. Remember, this number comes off the periodic table. It's the decimal on there. Okay, in 1 mole. Okay, for hydrogen, it's 1.01 grams in 1 mole. And for oxygen, it's fine around a 16 for oxygen. Okay, grams crosses out. All right, I'm doing this math right now. So what I'm going to do is take 3.6 divided by 12.01. All right, so this number right here is 0.299. I'm going to go ahead and go out a few decimal places. That normally helps make sure whole numbers look better. All right, so this one So I just took 0.9 divided by 1.01, and the number that my calculator gives me is 0.8910. We'll round it up to 9. Like I said, I think it's going to be better for you to go out several places when you're finding the moles to make your decimals look better. Okay, so here we'll take 2.4 divided by 16. All right, and this one is 0.15. Okay, so there's all of them converted to moles. The smallest one is here. 0.15 is smaller than those. So I'm going to divide all of them by 0.15. Okay, that means this one will be 1. Okay, so I'll do this one in my calculator now. 0.8910 divided by 0.15. I highly encourage you to do these along with me in your calculator. Okay. 0.29975 divided by, okay. All right. So we need whole numbers. All right. But I'm going to tell you, sometimes you have to use your judgment. If your number comes out to be 0.9, like these, it's okay to go ahead and call this 2. It's okay to go ahead and call this 6. And this one is 1. They do have to be whole numbers, but if it's 0.9 or 0.0, so if I had divided these and gotten 5.01, I could leave that at 5, okay? So the only time it's okay to round to whole numbers is if it's 0.9 or 0.0, okay? So what I may do here is these are some notes for you. I would definitely write these down in your notes. So if decimal is 0.0 or 0.9, round to whole number from right there. Round to whole number. Okay. For instance, 1.9 equals 2, or 6.01 equals 6. All right. These are examples. These are okay to round. Now, if decimal is 0.5, okay, use 2 to multiply. For instance, 3.5 times 2 would make your whole number 7. All right. We're out of room again. So make sure you write these down. I'm fixing to change this again so I can do the last 2. If decimal is 0.33 or 0.66, multiply by 3 is your number. For your example, 2.33, if that was the number that it came out to be, you would multiply it times 3, and it would get you 7. That would be your whole number, 7. This is your example, okay? All right, if the decimal is 0.25 or 0.75, multiply by 4. Okay, example. 2.25 is what your number came out to be. So if you multiply by 4, you get 9 as your whole number. All right, make sure you write all that down. You're going to want it.